instructional video for the latest laboratory, Hubble's law, and it is based on the 1929 result by the famous astronomer Edwin Hubble, and in which what he did is that he measured the redshift of a nearby galaxy and found out that the farther away the galaxy is, the higher the velocity it is at, okay? And of course, we do not measure the velocity of the galaxy directly. What we do is that we measure the redshift, and if you don't know what that is or you've forgotten, you have to go back to review what a redshift is, going back to the previous chapters. But then we convert that redshift to velocity, and you will have to do that in this lab, okay? So we measure the redshift, convert velocity, and then plot this velocity versus distance, and you will see this trend line here that in this simple graph, it implies something extremely huge about this universe, and that is it is expanding, okay? Of course, this was the famous 1929 plot by Hubble. We have since, for after 100 years or so, we have since done much better than that. And now we can use actually stellarium to sort of mimic what we could actually see. And so this lab has three parts. You're going to go through part A, go through some basic exercise and some reading, go through part B, and if you follow this instruction correctly, your stellarium will look like this with what we call hints, okay? So basically just this little artificial red marks, elliptical marks, marking the location or the observation of each galaxy that could be observed under this proper setting. That's what it's supposed to look like, okay? So follow the instruction, and your stellarium should look like this, okay? And so you are going to follow the exercise instruction for part B as well. That's pretty straightforward. The most important part of this lab is part C, okay, in which you're literally going to construct these data. You're going to pretending you are making observation, but of course using stellarium to fake that, to mimic the observation, following the instruction. You're going to come down to table 3, all right? So table 3 has 1, 2, 3, 4 columns. You're going to randomly choose galaxies, okay? You can, for example, this example IC4AA4 is given to you just as an example, but you can really click on any random galaxy, so pay attention. So let me just zoom in. You don't have to do this. Okay, let me just click on this right here. So this is NGC3AA2. And the most important information that you want is the redshift, okay, and the distance that's right here, okay? The distance and the redshift right here, okay? And you see the distance here is given either in parsec, megaparsec, MPC, mega, PC, megaparsec, or mega light year. Oop, I lost it right here. All right, so you see it's either 23.7 megaparsec or 77.3 mega light year. For this lab, we are going to use parsec, okay? I mean, typically astronomers also use light years, but megaparsec is more common, and for the purpose of expressing Hubble's constants, the most common standardization is using megaparsec, okay? So we're going to use megaparsec. So you're going to write that number here, okay? So your distance is in megaparsec. Make sure again, megaparsec, and you write your redshift. Okay, so let's go back. Your redshift information. See, read it carefully. Sometimes this visual is in the way. So you see the redshift for NGC3AA2 will be 0.006145. Okay, so you write that right here. All right, and so you're going to do this for every galaxy that you randomly clicked on. One of the suggestions that I will give to you is this. This is like the whole sky that you can see. Randomly, don't concentrate on one area. Click. I mean, technically you could. Okay, you can, but try to spread out a little bit. Okay, and then just randomly click on a different galaxy. Now, not only that, be a little bit selective, because we're not really trying to do real astronomers' work here. A real astronomer will do as many observations as possible. But here we're trying to do a short lab, and we're only going to pick around 20 to 25, right? So just enough to fill out this table. So what you want to do is you want to pick a set of galaxies, okay, that goes from, for example, 1 megaparsec all the way to 100 megaparsec. Okay, so don't try to just get everything that's around 50. The problem is if you don't spread out enough. Okay, so the problem is if you don't spread out enough, then you get a bunch of data concentrated in just one small interval. So you want to spread out your distance. Okay, so make sure you have a whole bunch of you have a set of different galaxies that spread out between, say, 0 megaparsec to, say, 100. I've actually randomly clicked on this for a while. For example, I clicked on this NGC 63 and this 58. That's not too bad. This one, okay. Some galaxy actually don't have a distance given. I do not know why, but it's not given. This one is 45. It's not too bad. Let's see if we can find some that's a little bit lower. Okay, this one is 32. Let's see. So right, you just go through it. This one's 15. Oh, that's not bad because we had 70 before and now it's 15. Can we find something that's even lower? Okay, 23. That's not bad. Oops. Wrong click. So let's see. Can we clicks on here? Well, anyway, you get the idea. Just try a few. See some that actually do not have a distance given. Right, not all of them has distance given. 23, so 60, right? So it's 59. Right, so you see, it's not as easy as you think, right? So okay, this one is 20. It's a little bit on the lower side. Okay, this one is 15, right? So if you try hard enough, you can actually find sort of good range anywhere from 5 to I was able to find something as high as 120. Okay, so that's what you want to do. Spread them out here. Okay, don't just concentrate everything, say between 50 and 70 megaparsec. That will be a bad set of data. Okay, so get a set of galaxy with distance that's between 0 and up to 100 or something. Okay. Now, once you have this redshift data here, of course, don't forget the redshift, and that's usually, see, this one is interesting. This one has distance, right? But it's in light year, so it's not very good. But the redshift is not given. At least I don't see it right away, okay? And so you go to a different one. It's not always possible, right? See, this one, 33, so don't forget the redshift. That's below, typically below the distance right here. So whatever you find for each galaxy, write the redshift here. And what you need to do to convert redshift to velocity is to use this formula. Okay, and that is explained in this lab as well as in the lecture. And that is to multiply this number by 300,000. Okay, just don't overthink this. Multiply your redshift z right here by 300,000 to get this velocity in the correct unit of kilometers per second. That's what we want. We want the velocity to be in kilometers per second. That's what we use. That's what has been standardized. Okay, and so I will give you some hints, and that is redshift should all be low. Okay, it shouldn't be like 1.0. That's just not the way it's going to work in the way Stellarium is given to you. Okay, all this nearby galaxy that we are observing are typically low redshift, 0.01, 0.001, at most 0.05 or so on, okay? So you're not going to get anything that's too high. And your velocity, see, this is a very good and representative velocity. You may get some that's around 1,000. You may get some even as low as 500, or you may even get some as high as 5,000, 6,000. But it won't be too low or too high. Okay, you want also, this will also be a spread out. Okay, so that's what you're going to do. You're going to get a distance in megaparsec and velocity in kilometers per second. And you're going to make a plot. You will make a plot, velocity over distance, velocity over versus distance. Velocity is your y-axis. Distance in megaparsec is your x-axis. You can do it two ways. You can do it using Excel or any graphing application you know how, and generate a plot, or you can do it by hand, right? Because not all of you will know how to do this using computer technology, right? And so if you know how to do this plot by some kind of graphing application or even Excel, just go to YouTube and search for keyword how to plot regression line or trend line. Yeah, look for the word trend line using Excel, and then you would and go through that exercise yourself. If you really do not know how to do that, do it by hand. Do it the way you know how to do in high school. Plot velocity versus distance, okay, on a graph paper. Visually draw a line through those data. It should look like this. Okay, it should look like this. You get a bunch of scattered data like this, but it should have a clear trend line going up like that. And then you visually determine what's the trend and draw what do you think is the best line fit. It's okay if you don't get it too accurate. For as long as it looks reasonable, I would accept it. And then by eyes, okay, but of course calculate your estimated slope. Do your best work, okay? Go back, sort of think back in high school when you draw on a graph, how do you determine the slope? Is it, and that is rise over run, okay? And the slope of the line is the Hubble constant. And that is the key for this lab. The most important things about this lab is this table number 3, plus the graph, okay? Plus the graph. So please show me the graph, either by hand, you can take a picture, or use Microsoft Excel, the Excel spreadsheet, or any graphing application, okay? And then go through exercise D. Show your work. Show your work. Don't just write down a number. Show your work. Okay? For any questions, you can email me and ask to clarify any confusions.